Welcome to the math record. Today I'll be using derivatives for optimization. So what is optimization? Well, basically optimization is just a way to find the best answer to a problem. So to understand this, we're just going to do some examples. One of the main optimization questions is maximizing area. So let's just do a problem like that. So let's say someone wants to build a rectangular fence along the side of their house. And let's say they only have 100 feet of fencing. So what is the maximum area that they could build? Well, let's say we have a house, and let's say we have a fence along that house. So something like this. And it's rectangular, so that means this length is the same as this length, and that means this length, we'll just call it L. So since they have 100 feet of fencing, that means W plus L is 100. So that's 2W plus L. And the area is calculated by width times length, so area equals width times length. So I noticed that we could have two variables in two equations, so let's just kind of substitute our ln because it's the easiest. So that means 100 minus 2w. And we want to optimize this area, this equation, because we want to optimize area. So when we're dealing with optimizing for max and mins, right, we're dealing with derivatives. So taking the derivative of this, actually, let's simplify this further first. So let's say that's 100w minus 2w squared. Then we're going to take the derivative. So that's 100 minus 4w. So this will be our derivative. So when is our derivative? So if we have a maximum area or at some point, what will be the derivative at that point? Well, the keyword is maximum. So when we're dealing with max and mins, the derivative is going to be at 0. So that means 100 is equal to 4w. That means divided by 4, we get 25, which equals w. Plug this back in to get our area. So 100 times 25 is equal to 2,500 minus 25 times 25 is 625. And 625 times 2 is 1250. And that will equals to 1,250. And since we're dealing with feet, that means the area is feet squared. Okay, so how do we check that this is the maximum? Well, we could use the second derivative test, which states that if we have a maximum point, max or minimum point, if the second derivative is positive, that means it's concave up. Then it's gonna be it's concave up. Then it's gonna be a minimum. But if the second derivative is negative, then it's concave down. Then it's a maximum. So we just need to check that the second derivative is negative. So we already have our first derivative. Taking the second derivative. Derivative of 100 is 0. Derivative of negative 4w is negative 4. So it's always going to be negative. That means it's always concave down, which means this is going to be a maximum. And that is our answer. Okay, let's do something else other than maximum. Let's deal with the minimum. So when we're dealing with minimum, this usually deals with cost. So let's say we have a box. Let's say that's a square prism. And let's just draw this box. And let's say this box has a volume of, let's say, 100 units cubed. Okay, and since this was a square, let's call this x, and we'll call this x, and let's call this one y as our height. So our volume, which is 100, is equal to x squared times y, because it's x times y. Okay, and let's say that the cost of making this box, let's say the top and bottom areas cost $10 each. So $10 for the top and the bottom. And let's say the sides, so the four sides, each of them cost $5 for the sides. So how do we minimize the cost? Well, we make a cost equation. So it takes $10 for the top and the bottom, so there's two of them. And the top and bottom, it's an area, so that is x times x for both of them. So it's just x squared. Now the cost of the sides, they're $5 each. There's four sides, and each side is calculated by its base times the height, which is x times y. So we get the equation 20x squared plus 20xy. As usual, we want to substitute one of the variables in, so let's substitute our y. So that will give us c is equal to 20x squared plus our y is just going to be 100 over x squared. So 100 over x squared times 20x would be 2000 over x. Okay, and as we did before, taking the derivative and set it equal to 0 to check for max and mins, because that's what we're looking for. We're looking for the minimum cost. Then the derivative of 20x squared is 40x. The derivative of 2000 over x is negative 2000 over x squared. So simplifying this, multiplying this by x squared on the numerator and denominator. So we get 40x cubed, sorry about that, and 2000 minus 2000 over x squared. And we set that equal to 0 to check for max or mins, or it's undefined. So it's undefined if this portion is on the bottom. So that means x has to equal 0. That means x has to equal 0. So if x is equal to 0, going back to this formula, that means there's no way for this side to equal this side, because then this side will equal 0 and this side equals 100, which cannot be true because they cannot be equal. So there's no conditions where it's undefined, so it's equal 0. So that means 40x cubed minus 2000 equals 0. X cubed minus 2000 equals 0. So 2000 divided by 40 is equal to 50. And let's make sure that's true. Yep, that's true. So that means x cubed is equal to 50. That means x, just got right on the side, x is equal to cube root 50. So that is going to be the length of our side. So I'm just going to delete this because I need room to do a little bit more math. And let's delete this stuff right here. Okay, cool. So now we just need to check if this is the the minimum cost. So doing the second derivative. This would give us our minimum cost. So taking the second derivative, the derivative of 40x is 40. The derivative of 2000 over x squared. So this would be plus 4000 over x cubed. Okay, so obviously when you plug x in here, a positive divided by a positive is positive, plus another positive would be overall a positive. So that means the second derivative is positive at this point. So if it's positive, that means it's concave up. So how it'll look will be like at some portion of the curve where it's a minimum cost at this point, then it's concave up. So it's actually a minimum. So we know it's true based on the second derivative test. So since we know that it's a minimum, then we could just plug this in to get our cost. So our minimum cost would be 20 times cube root of 50 squared plus 2000 divided by the cube root of 50. And you can plug this into your calculator to get an approximate answer, but this is the exact answer that will give us the minimum cost while giving us 100 units cubed for our volume. Well, thanks for watching, and in the next video, I'll be covering indeterminates.